Hello friends, today we are going to start one of the most important topic of interference of light, that is Newton's rings. Now this Newton's rings, that experiment, you will perform it in the lab also. Here we will discuss the theoretical portion which you can apply it directly into the experiment when you will perform this in the lab. Newton's rings, they are obtained by using interference of light rays. Interference we have already discussed that either it is constructive or it is destructive. So constructive means where bright fringes are obtained. Destructive means where dark fringes are obtained. How this bright and dark fringes are obtained in Newton's rings? Let us see that. First of all, the basic part of Newton's ring where the whole interference takes place is this diagram. If you check in this diagram, there is one glass plate on which a plano-convex lens is placed. Now the point where the lens touches the glass plate, there is an air film in between the two. The interference fringes are obtained at the point of contact between the two. How it is obtained, that we are going to discuss it here. Now if you see the second diagram, here comes the illustration that a ray of light when falls on the plano-convex lens, part of the light gets reflected and a part of the light gets refracted. The reflected light from the lens, after refraction comes out of the lens, refracted light falls on the plane glass from where it gets reflected, and that reflected light when comes out of the lens superimpose on the first ray and interference fringes are obtained. These interference fringes are circular in shape because of the curved portion of the convex lens, which is a part of the whole circle. Therefore, the fringes are also circular in shape, and that is formed by reflected light. Now the main experimental arrangement of this, it consists of a source of light and a convex lens, a glass plate placed at an angle 45 degrees to the incident light, and the interference fringes are obtained and seen through a microscope. The light when falls on the glass plate gets reflected on the plano-convex lens such that at the point of contact of the glass plate and a plano-convex lens, interference fringes are obtained. Now these interference fringes, which are circular in shape because of, as I said, the curved part of what? The convex lens, the plano-convex lens, these rings which are alternatingly central dark and bright fringes are known as Newton's rings. Now it should be pointed out that in order to observe the fringes, microscope has to be focused on the surface of the film. Each ring will be locus of all such points where thickness is the same. So let us start with the condition of interference where the bright rings are obtained. Now as we have previously calculated, if the path difference is integral multiple of lambda, then how that bright and dark are obtained? If it is n plus half lambda, then when bright or dark fringes are obtained. Since here the light is reflected from the two parts and interference takes place. So the path difference, which is 2 mu t cos r previously obtained, must be equal to 2n plus 1 lambda by 2. Air has a refractive index 1. N is the order of the fringe. Since angle is very small, so we will take r cos r is equal to 1. From here we can write 2t is equal to 2n plus 1 lambda by 2, where n can be 0, 1, 2, 3 or so on. This is the order of the fringe. Similarly, for the dark fringe, 2 mu t cos r must be equal to n lambda. Again, for air film, refracted index is 1. Small r, we have the dark rings 2t is equal to n lambda. Now let us come to the mathematical part of it. How do we calculate the various factors like radius of the different bright and dark rings? Concentrate on this particular figure. If you see that plano-convex lens is a part of that complete whole circle, a sphere whose radius is equal to O, radius is R, center is O. Let us take thickness of the glass air film is equal to Tn. Therefore, if OM is R, AM is Tn, so what is OA? It is equal to R minus T. From M to N, it is Rn. Now we want to calculate the radius of bright and dark rings which are obtained in this experiment. So let us come to the mathematical part. Here, from the triangle O, A and B, if we check this triangle O, A, B, then Pythagoras theorem says that hypotenuse square is equal to perpendicular square plus the base square. So I am going to use that. Here comes that r square is equal to r minus t whole square plus rn square. So take rn square on one side, it is r square minus that. Open the square and solve it. You will check it is 2rt minus t square since r square cancels. Now since r is very large as compared to t, so t square is very small, hence neglecting. So what do you get? Rn square is equal to 2rt. What is t? Rn square upon 2r. Now let us find the condition for bright rings. 2t is equal to 2n plus 1 lambda by 2. Or putting the value of thickness, it is 2rn square upon 2r is equal to 2n plus 1 lambda by 2. Or rn square is equal to 2n plus 1 lambda r over 2, or rn is under root of that. Therefore, what is diameter? Twice the radius. It is equal to twice of this factor, where n is equal to 0, 1, 2, 3. Right? Now, this is the diameter of bright rings. If it is dn for bright ring, let us write for dark rings. For dark rings, 2t is equal to n lambda. Again, put the value of thickness. Rn, the radius of the dark ring, is equal to n lambda r under root. Or diameter is twice, so simply equal to 2 times under root n lambda r. Now, if I put n equal to 0, you can check this diameter come out to be 0. What does that mean? At the center, we are going to have a dark ring. That means a dark ring is obtained at the center. Then comes bright, then comes dark, and then comes bright, and so on. Now, the radius of the bright ring is equal to under root lambda r by 2 from this particular equation. So, alternatingly, bright and dark rings are obtained. The spacing between second and third dark ring is smaller than spacing between the first, second one, so on. For example, let us take this one, lambda 1 in diameter of first, second, third and fourth. Keep on putting the value of n equal to 1, 2, 3 and so on. And check it, d4 minus d1 is twice, d9 is equal to 6, d16 is equal to that, or difference of 16 minus 9 is equal to this. It gives you 8 fringes. Now, fringe width, this is the most important point. Fringe width decreases with order of the fringe, and fringes get closer with increase in their order. What is fringe width? It is nothing but the distance between the two consecutive bright or dark fringes, right? So that will be decreasing as we go away and away. That means order is increasing and they come very close with each other with the order. Now, how do we calculate? What is the first application of Newton's rings? This is wavelength determination of the source of light. So, how do we calculate that? Let us take it as radius of nth dark fringe, which is given by Rn square equal to n lambda r, or dn square upon 4 is equal to n lambda r, or dn square is equal to 4n lambda r. Similarly, n plus mth dark bent dn plus m square is equal to 4 times n plus m lambda r, or dn plus m square minus dn square is equal to 4 times that minus this. Check lambda is equal to dn n plus m square minus dn square upon 4mr. Now, let us take one example. How do we calculate it? Suppose you want to find the diameter of 6th and the 16th ring are determined. Then m is equal to 10. So, lambda can be written like this. Where, what is r? You know that r is the radius of curvature of the plano-convex lens. And how do we find it? It is by using a spherometer. Use a spherometer, find the radius of curvature of plano-convex lens, put the value here for r, diameters are known to you, hence what you can calculate? The wavelength of the source of light. If it is a sodium lamp, that for yellow light, you can find the value, you can compare it with the standard one, but 5890 or 5896 angstrom, you know the other two wavelengths of the light. What type of the fringes are obtained? Now if you check it, this type of the fringes are obtained on that point of contact between that of that glass plate as well as what? The plano-convex lens. With the help of the microscope only you can see these type of the fringes which are generally obtained. Or like this. This is a close-up of Newton's rings. This was reflection method by which you can calculate the various things. Now next we will discuss with the transmitted light. That will be the next lecture. Thank you.